everybody, getting ready to do lesson chapter 12, review and summary, part 2 of pre-algebra today. In chapter 12, review and summary, part 2, it has 56 points here on your class worksheet, and then 37 points will go into your notebook or your notebook guide. Have that out. Students, put your name, date, period here, and then due date for my onliners and homeschoolers. And let's go right into slide number 1 here. 12.3, multiplying monomials and polynomials. Example, find the product of x times quantity 5x squared plus 3x plus 2. So how would we find this product here? X times quantity 5x squared plus 3x plus 2. So what we're going to do here, we're going to use the distributive property. We're going to distribute x to each one of these terms. Inside the parentheses, x times 5x squared plus x times 3x plus x times 2, using the distributive property for that. And then when we multiply out, the product of powers property, x times 5x squared would be 5x cubed. Then x times 3x would be 3x squared. And then x times 2 would be 2x here. So we come up with that. So that would be our multiplication there. That would be our product of this expression up here. Okay, find the product up here. Negative 5n squared times quantity 5 minus 3n. Students, this is yours down here. We're going to do this up here right now as our guided practice. So negative 5n squared, we're going to distribute that to each one of these terms inside parentheses. So negative 5n squared times 5 minus negative 5n squared times 3n. So negative 5n squared times 3n. And this would be negative 5n squared times 5 be negative 25n squared. And then a negative of a negative would be positive 15n cubed. So this would be your product here for this expression up here. Into our next example here, we're going to go into 12.4, multiplying binomials. So find the product of 5x plus 4 times quantity 2x minus 7. So for this binomial here, to find that product, we go first, outer, inner, last, which is FOIL. Remember, students, first, outer, inner, last, that spells FOIL. So for the FOIL here, we got 5x times 2x plus 5x minus 7 plus 4 times 2x plus 4 times negative 7. So we're going to write here the product of terms, and then we're going to multiply these out, which we will get 10x squared plus negative 35x plus 8x plus negative 28. So now all we need to do is combine like terms, and we got 10x squared minus 27x, negative 35x plus 8x would be negative 27x, and then minus 28. That would be your combination of like terms using FOIL. So we're going to find this product here, quantity 8a plus 7 times quantity 2a plus 9. And then this is yours down here, students. Let's do this one up here first. So for this product up here, 8a plus 7 times quantity 2a plus 9, we're going to again use FOIL. So 8a times 2a plus 8a plus 9 plus 7 times 2a plus 7 times 9, and this is 16a squared, plus 8a times 9 would be 72a, plus 7 times 2a would be 14a, plus 7 times 9 would be 63. We're going to combine like terms now. We got 16a squared plus 86a, which is a combination of these two terms, plus 63. On to our next example, which will be 12.5, other rules of exponents. Simplify the expression 3y to the third power, and then we have 7 over k to the second power, and then negative 2m to the fourth to the third power. So how do we find the simplifications of these expressions. So we have 3y here to the third power, which would be the same thing as 3 cubed times y cubed, power of a product property. And then when we extend that out, we get 3 cubed, which is 27, and then just times y cubed. That'd be the power of a product property of this expression here. And then for b, which would be 7 over k squared, 7 over k squared, so we got 7 squared over k squared, power of a quotient, we have a quotient here. And then when we simplify that, we have 49 over k squared. That would be this simplification or the extenuation of 7 over k squared. And then we have for c here, we got the quantity negative 2m to the fourth power. All of that would be cubed inside of parentheses here. So that'd be the same thing as negative 2 cubed times m to the fourth power cubed. And then once we cube that, we got negative 2 cubed times m to the 12th power. What's negative 2 cubed, students? It'll be negative 8m to the 12th power, which would be the evaluation of this expression here. Okay, let's go into our guided practice. Simplify the expression. Write your answer using positive exponents. So we have z to the negative third power, all of this inside to the negative fourth power. So to evaluate that, what we need to do is z to the negative 3 to the negative fourth power. So to do that, this will be a negative times a negative 3 will be z to the 12th power. That would be the simplification of this expression here. And then students, this is yours down here. Do that on your own. Okay, moving on to our next example here, which would be 12.6 quadratic functions. Graph the function y equals x squared minus 2x minus 1. So to graph this function here, we're going to make a table of values, choose several x values, and find the corresponding y values. So we have when x equals negative 1, y equals 2, 0 is negative 1, 1 is negative 2, then 2 is negative 1, and then 3 would be 2. For when x equals 3, y equals 2. So we have a table here of values. So use the table to make a list of ordered pairs. Here's our ordered pairs, negative 1, 2, 0, negative 1, 1, negative 2, 2, negative 1, and 3 and 2. So here are our ordered pairs. So now graph the ordered pairs, then draw a smooth curve through the point. So when we do that, we come up with this parabola here. Here is our plot for our ordered pairs. When x equals negative 1, y equals 2. X equals 0, y is negative 1. When x equals 1, y equals negative 2. When x equals 2, y equals negative 1. And then when x equals 3, y equals 2. And they plot one. No, they don't. That's the last plot. And then we just make a smooth curve through these ordered pairs, through these points. And we come up with this parabola. Okay, let's try one here. Make a table of values for the given function, then graph the function. So we have y equals negative x squared minus 4. So for this one, to make a table for that, we have when x equals 0, y equals negative 4. When x equals 0, y equals negative 4. Here's one ordered pair here. When x equals negative 2, y equals negative 8. So when x equals negative 2, y equals negative 8, we're down here. This is a negative, so you know your parabola is going to be pointed down. You should know that. And then when x equals negative 1, y equals negative 5. So when x equals negative 1, y equals negative 5, which should be down here. And when x equals 0, y equals negative 4. And then when x equals 1, y equals negative 5, which should be down here. And then when x equals 2, y equals negative 8. So when x equals 2, y equals negative 8. So here, once you make those plots, and then you can graph, here is our parabola here for this equation up here, this quadratic. And moving on here. So our next 12.7, exponential growth and decay. The This year, 10,000 people attended a benefit concert. The concert's organizers want to make it an annual event. So they predict the attendance A in T years using the function A equals 10,000 times 1.05 to the T power. When will the attendance exceed 12,000? So which year will the attendance exceed 12,000? So let's make a table of values here using this function. When T equals 0, Y equals 10,000. T equals 1, 10.5. T equals 2, 11.025, and then 3 will be 11,576, etc. So it seems like for year 4, it would exceed 12,000, 12,155. So from the table, you can see when T equals 4, attendance will be greater than 12,000. And so the attendance at the benefit concert will exceed 12,000 after 4 years using a table. Okay, let's try another example here. You deposit $450 into an account earning 4% interest, compounded annually. The balance A of the account is given by the function A equals 450 times quantity 1.04 to the T power, where T is the number of years after the deposit. After how many years will the account have a balance greater than $500? So the answer for that can be solved by putting all this into a table. When do we get over 500? It'd be for 3 years here. Plugging in our values here into T, and we get to 506.19 on year number 3. So the account will have a balance greater than $500 after 3 years. Moving into our next example here, 12.8 sequences. Tell whether the sequence is arithmetic or geometric, then find a common difference or common ratio and write the next 3 terms. So here we have 6, 10, 14, 18. So each term after the first is 4 more than the previous. So the sequence is arithmetic. The common difference here is 4. Let's try another one. 13, 65, 3, 25, 16, 25. Each term after the first is 5 times the previous. So the sequence would be geometric. Common ratio is 5. The next 3 terms in the sequence, in this sequence, will be 8125, 40,625, and then 203,125. This would be a geometric sequence here. So let's try one here. Tell whether the sequence is arithmetic or geometric, then find the common difference or common ratio and write the next 3 terms. So we have 321, 147, 1029. So what kind of sequence is this, students? So this thing here is geometric because it's each consequential term is 7 times the previous. The common ratio will be 7. The next 3 terms in the sequence will be 7203, 50,421, and then 352,947. So this would be a geometric sequence here. Students, don't forget to do this one down here. And that is Chapter 12, Review and Summary, Part 2, Pre-Algebra Math, Animated PowerPoint Math Video, AOL.com for questions or course materials. Thank you very much.